Hello everyone, today I'm going to be talking about a show of force. This is Monique.
And this is Lekana.
So, to start, what's gravity? Gravity is the force by which a planet or other body draws objects towards its center. The force of gravity keeps all of the planets in orbit around the sun. Gravity is an invisible force that acts like a giant net, pulling everything with mass towards each other. The Earth, like a massive ball, creates a stronger pull closer to its center. Just like the tighter the weave of the net, the stronger the grip. As we move farther away, the Earth's mass seems to spread out, weakening the pull, similar to how a looser weave provides less grip. So, Newton's universal law of gravitation states that the force of attraction between any two bodies is directly proportional to the product of their masses and is inversely proportional to the square of the distance between them. This law states that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of distance between them. And these are the units that we're going to be using for today with its mathematical representation, where F is the gravitational force between the two objects, G is the gravitational constant, M1 and M2 are the masses of the two objects, R is the distance between the centers of the two objects. Before I explain the graph, here's the mathematical representation. So, this graph represents the gravitational force between Earth and G. Acceleration due to gravity. We can analyze the graph to see how gravitational force changes between the Earth and the rocket during its journey to the moon. As we can see from this graph, gravity weakens the distance we can see from stage 1 to stage 8a. The solve for G line represents the acceleration due to gravity, shows a clear downward trend. From stage 1 brackets 3.599 G to stage 8A brackets 0.0068 G, the force of gravity acting on the rocket weakens. As the rocket travels farther away from Earth, the distance indicated by the distance from Earth line, the force of gravity decreases. We can observe that there's a decreasing trend in the gravitational force from stage 1 to stage 8a. This trend suggests that as the rocket moves away farther from Earth, the gravitational force weakens. Gravity follows an inverse square law, which means that the force of gravity decreases as the distance between the two objects increases. In this case, as the rocket moves away from Earth, the distance between the rocket and Earth increases. Consequently, the force of gravity between the rocket and Earth weakens, resulting in a decreasing trend in the gravitational force. After stage 8a, there is a change in the trend of gravitational force, and it gradually increases from stage 9 to stage 15a. This shift in trend suggests that as the rocket gets closer to the moon's gravitational force starts to influence the rocket's trajectory. As the rocket moves towards the moon, the gravitational force exerted by the moon becomes more significant compared to the weakening gravitational force from the Earth. The moon's gravitational force starts to counteract the decreasing force of gravity from Earth, resulting in a gradual increase in the overall gravitational force experienced by the rocket. This change occurs because the rocket entering a region because the gravitational force from both the Earth and Moon are at play. As I forgot to mention, there might be some minor fluctuations on stage 2A and 4A. This could be due to the rocket's specific movements or thruster firings during that stage. From stage 9 onwards, the solve for G value remains relatively constant around 0.0068 G. This suggests that the force of gravity has reached a level that remains fairly steady as the rocket travels further towards the moon. So, gravity flattens out at a great distance from Earth. So, the increasing gravitational force from the stage 9 to stage 15a is due to the combined effects of the moon's gravitational pull and the increasing distance between the rocket and the moon. The increasing gravitational force does have an impact on the rocket's speed. So, as the rocket moves closer to the moon's gravitational force becomes more significant, leading to an increase in the rocket's speed. Precisely, the acceleration of the rocket is likely facilitated by the combined effects of moon's gravity and increasing gravity from Earth. This graph confirms that the force of gravity weakens significantly as the rocket travels further, which aligns with the understanding of the law of universal gravitation. And here are the citations. Thank you for listening.